visual ways that you might think about decimal multiplication. There are a way that you might relate addition, repeated addition, like with the same add-in repeatedly, with multiplication. That's probably how you first were introduced to multiplication back in the day. And also, you could think of the fraction equivalency of these decimal numbers. And those are two other numerical ways that you might interpret decimal multiplication. So I'm going to go ahead and just pick, let's see, oh, I thought I turned this on to let me do a scribble. Um, yeah, it says it's on scribble. Oh, there we go. Let's do my birthday, 8.17. That is supposed to be a 7. I'm drawing with the mouse pad thing. Actually, no, with an actual mouse. Even so, it's not so pretty. 8.17, or 8 and 1700ths. Let's say I want to add those up, right? So I have 7 plus 7 plus 7 is 21. There's the 1, carry the 2. So I have 2, 3, 4, 5. I don't need any carries. As we talked about when I do decimal addition, a lot of times I put my decimal point in as I get to it. And then 8, 16, 24. So repeated addition is what basically multiplication is the shortcut for. So this would also be the same problem as 3 times 8 and 17. I'm having trouble drawing that little decimal point there. There we go. 3 times 8 and 1700ths equals 24 and 50 100ths. So we'll look at the algorithm on how to compute this without having to do all this addition on another day. But this is something that also is a way that you might interpret decimal multiplication. And then finally, I wanted to do connecting it to fractions. So in the past, you were supposed to have done fraction multiplication. The idea behind it is if I have, let's say, 3/10 times, let's pick 7/100ths. When you multiply fractions, our best strategy is to simplify before we multiply, but none of these numerators can be simplified with any of these denominators. So you're going to multiply across the top. So 3 times 7 is 21. And you multiply across the bottom. 10 times 100 is 1,000. So what happens here, well, is that my 0 right there didn't close up, which is very frustrating. That is the ugliest 0 you're ever going to see. What happens here is this could have been computed. And again, on another day, we'll show the strategy for computing with decimals. So 3/10 would be 0.3. 700ths would be 0.07, because we want the 7 to end in the hundredths place, tenths, hundredths. And the answer would be 21 ending in the thousandths place. So 0. I like to put that 0 point before the decimal point because it makes it more clear that it's not just some random speck on the page, but there was an intentional 0 there. And then I have to go tenths, hundredths, thousandths. So I need the 21 to end over in the thousandths place, which means I do need a 0 here to make sure it gets over there. And so this is equivalent to that. And just like this addition is equivalent to that multiplication. So just a couple of other ways to think about decimal multiplication. And again, we will look at how quick and easy the decimal multiplication is. But first, I just want you to see the magnitude of the answers that you would anticipate and the decimal location by doing it through other methods initially. All right, I hope that was helpful for the activity you're going to do next.